So now let's look at the actual algorithm, which is the depth first traversal algorithm that can be used to find out all the nodes that are reachable from a particular given node. So the depth first traversal algorithm will explore a path all the way to a leaf node so basically, what is a leaf node? A leaf node is a node with the out degree equal to 0, right? So basically, we'll dig down as deep as we can until we reach a leaf node, and then we traverse back to its immediate ancestral node where there is an unvisited node. So this solves the issue of reachability, the problem that we are addressing using the depth first traversal algorithm is that of reachability, right? So the algorithm provides us with a set of nodes that are reachable from the given root node. Okay, so let's look at the input to the depth first traversal algorithm. The input to the algorithm is a graph G having vertices V and edges E, right, and a root node R. Now use the root node R is the node where you want to find out all the other nodes that are reachable from that root node R, and the output that DFS provides is a set of all vertices reachable from the root node R, right? So let's work out an example on the DFS related to a tree. So for example, in this tree we have let's select 0 to be our root node. Yeah, now starting from 0 we can travel either to node 1 or node 2, right? So now let's say we pick node 1, right? Now picking node 1, we move to 1. Now from 1 we can either go to node 3 or we can go to node 4. Say we pick node 3. After going to node 3, what we observe is that the 3 is our leaf node. So now we cannot go any further deep into 3. So we have this concept of visited nodes. Now what visited node is? A node that has been traversed during a DFS traversal, right? That has been visited during a DFS traversal. A node visited during DFS traversal. So let's keep a note of what all nodes that we have visited till now. We have visited node 0, then we visited node 1. Yeah, then we visited node 3. Now that we have visited 3, we see that there is no 3 is a leaf node. So we trace back to an immediate ancestor of 3 that has an unvisited child, right? So as we know, a child is the node is the target node from the source node, right? So for so we trace back to 1, right? When we trace back to 1, we see 4 is an unvisited child, so we move to 4, right? So we have visited 4. Let's add that to our visited list, right? Now after visiting 4, we can either go to 5 or 6. Let's say we go to 6, right? Then after going to 6, we have visited 6, and then we will since 6 is a leaf node, we will have to trace back until we find a parent with an unvisited child. So we come here, we see 5 is unvisited, we visit 5, and then we since 5 is a leaf node, we start tracing back. Now we see 1 has all its children visited, so again we have to trace back to 0. Now we see 0 has a child 2 which is unvisited, so we go ahead and visit 2. So we visited 6, we visited 5, and now we backtrace to 0 from where we visited 2. After visiting 2, we see 2 is a leaf node, and then we backtrace to 0. And after we have backtraced to 0, we have gone to all the reachable nodes from 0. So this is the output that the depth first traversal algorithm will give us. Will basically be the order 0, 1, 3, 4, 6, 5, 2. Now please bear in mind that this is not the only valid depth first traversal order. Another order could have been, for example, you start from 0, you go to 2, then you go to 1, then you go to 4, then you go to 6, then you go to 5, then you backtrace to 4, you go to 1, and then you go to 3, and then you go back to 1 and go back to 0. So this is also a valid traversal path. So like that you can have many paths that are valid starting from a given root node, right? Now let's take another example of a DFS on a graph, right? So let's pick a node. Let's say 2 is our root node, right? So we have 2 as a root node, right? So starting from 2, as we can see, the out degree of 2 is going to 3 and 1. So we can either go to node 3 or either go to node 1, right? So let's say we choose node 3, right? So let's maintain our visited list over here again, right? So 2 has been visited, and then we visited 3. Next we see that from 3 I can only go to 1. So that is the only option that I have available. I go to 1. Now from 1 I can either go to 0 or I can go to 4, right? Now so let's say I choose to go to 0, right? Now from 0 I can the only depth that I can encounter is going back to 2, but since 2 is visited, so now we will trace back to a previous ancestor, which in this case happens to be 1, with an unvisited child, which is 4. So we trace back here, right, and visit 4, right? After visiting 4 we will back trace again and come back to our root node, right? So we visit 4. Now as you can see, we have visited all the nodes reachable from 0. In this case we have not visited nodes 7, 6 and 5 because they have no links associated from 0, right? So we cannot visit those nodes. For example, another way of looking at it is, say we have suppose we choose 4 to be our root node, right, and start the DFS algorithm from here. Now I cannot go to any other node from 4 because there is no other out degree edge, right? There is no the out degree of 4 is 0, so there is no edge originating from 4. So basically the DFS, if I start from 4, I will not be able to reach any other node. So that would be a nice explanation as to why some nodes can be reached in the graphs. Some nodes can be reached from a particular point and some cannot.